Okay. So what is a linear system or a system of linear equations? Can I have a volunteer read for us this definition? What is a system of
I'll
linear
read.
equations? Go ahead, Ijara.
A system of linear equations, also called a linear system, consists of two or more linear equations that have the same variables. Oh, continue or
Yeah, sure, go for it.
a solution of a system of linear equations with two variables is an is any ordered pair that satisfies all of the equations in the system.
Cool. Awesome. Okay. So we've actually seen, like I said, we've already know what linear systems are because we've actually seen them before. Basically, a system of linear equations, which again, we kind of call it two things, system of linear equations or just linear system, is anytime you have two or more lines on a graph. Okay, so just anytime you see a graph and there's at least two lines right up next to each other, that's a system of linear equations.
Write this down.
Yes, so go ahead. I'm going to highlight the two definitions I want you to write down. Definition number 1 and definition number 2. All right, so go ahead and just take a moment to write those two definitions down, and then we'll kind of explain a little more what a solution is. I'll give you guys about 30 more seconds, and don't worry if you don't finish, because I will stay on this slide for a little bit longer past that.
Wait, so is this is like vertical and horizontal lines, right?
We're not just vertical and horizontal. We're going to be looking at lines that go all in different directions. Now, if you're done writing, the other thing that we will be doing is copying down these three graphs. But like I said, I'm going to stay on this slide for quite a while. So if you don't get to it right away, that's okay. But if you finish writing, you can start kind of copying down these three graphs. Make sure you label them. Okay, I'm staying on the slide. Keep writing, keep copying, but I'm going to start talking. So, like I said, a system of equations is when you have two or more lines, two or more functions, two or more linear functions graphed on the same coordinate plane. So graph A is pretty similar to what we saw in the bell ringer. In graph A, we see that there's one line going this way. I'm just going to call that one line A. And then we have another line that is going the opposite type of slope going this way. And that would be line B. Now let's just do a little bit of review. Which of those lines has a positive slope? Line A or line B?
Line A.
Good, good. Line A is positive, whereas line B is negative. And again, that all goes back to slope man, or that's just something that we kind of memorize. The direction that each line is going in will either be positive or negative. And in this case, line A is positive and line B is negative. And just like we said before, they intersect, or they cross at a certain point. Now, that point is the solution. And in this case, how many solutions do we see? Is it crossing one time or more than one time?
Once.
Yeah,
One.
just that one time. They meet and then they go away and they never touch again. So this is an example of a system of equations that has one solution, just one. And this is very similar to what we've seen in the past. In the previous topic, when you guys took your mid-year assessment, there were a couple of examples where you had two graphs and they only touched one time. But sometimes they would touch two times, maybe three times. And in this case, when we're talking about systems of linear equations, there's only going to be three options. They either touch one time, 0 times, or something called infinite solutions, where they touch all the time. And let's see what that means. So graph B kind of looks like it's just one line, right? Graph B, how many different lines do we see?
One.
Just one, right? But what it actually is showing us, and this is why I'm using my colors, I'm going to highlight it a little bit better. I want you guys to think of this as one line, line A, and then another line kind of just right smack on top of it. So this is still a system. It's just that both of the lines are located in the same exact spot. They are one right on top of the other. Now, a solution is the place where the two lines touch. But what's happening here? Are they touching one time or no times or kind of all the time?
All the time.
They're touching all the time, right? Like if you think about it, they're touching over here, over here, over there, over here, over here, over here. Basically every single place where they are, they're touching, okay? Because one is right on top of the other. So what we call this is infinite solutions. Okay, so if they're two different lines and they cross once, that's one solution. If they're two different lines that are right smack up on top of each other, that would be infinite solutions. And then we get to graph C. So what do we notice about this one?
They don't like come together.
They don't come together. Would they ever come together?
No.
No. What do we call these two types of lines? There's a special name for them. Does anyone
Parallel.
remember? Yeah, these are parallel lines. So let me highlight that a little bit better. Parallel lines are lines that have the same what?
Slope.
Same slope. Good. So here we have line A. We have line B. They have the same slope. They are parallel. So let me write that down. Let's see, where can I fit this? Parallel, same slope. And what that means is that since they have the same slope, since they will never ever touch, they have no solutions. So this is called no solution. So those are the only three situations that we will see for the next couple of weeks when we're learning about this topic. They either touch one time, so that's one solution. They might touch all the time, so that's infinite solutions, or they're never ever going to touch, that would be no solution. Do I have any questions so far?
How would we know that we're dealing with an infinite solution?
Good question. We are going to see an example today, and we will see an example every day this week, so you'll have a much clearer idea kind of at the end of the day. But think about this. Since it's one line right on top of the other, what do you think the equations of line A and line B are going to look like? Are they going to have different equations or pretty much the same exact equation? And this goes for anyone.
The same.
Exactly. Since it's pretty much located in the same exact place, line A and line B will have the same equation. So we'll see what that looks like. Okay. Any other questions? Does anyone still need a moment to finish copying?
Me.
Yeah? Okay, I'll give you guys about another minute. Alrighty. Anyone else still need a couple seconds?
Me.
Okay. All right. Go ahead. Luckily today is kind of a shorter lesson, so we can take time.
I'm done.
Okay, cool. All right, so let's go ahead and see what we're actually going to be looking at today. So first of all, today's entire lesson is going to be a lot of graphing, which means if you are writing things down in your notebook, you're not going to get a perfect graph during class today. However, your homework assignment on Khan Academy is going to be one of those assignments where it has like, you can kind of move around the line to get it to where you want it to be. So you'll be able to practice it a lot more during homework. It's just that during class, you won't, unless you want to go and copy all the little graphs little by little, that's fine, but it might take a little bit of time. So don't stress out if you're not able to practice it during class, because the homework assignment, like I said, has plenty of opportunities to practice graphing.
Can we write it in Word?
Yeah, so during class, what we will focus on is how to get, because what do we need in order to graph something? What are the two things? And this is all review, so let's think back. In order to graph a line, what are the two things I need?
Slope, intercept?
Slope, yeah, so the slope
And y-intercept?
and the y-intercept, exactly. So what you guys can do when you're writing in your notebook is write down the steps for finding those things. That way, because after that, it's not too hard to actually graph it. So here's what we're going to do. So we have a system here. Now, this is what we're going to see all week. This is how they're written. Notice I have that little like kind of weird parentheses thingy on the left side. That groups together the two equations that are in my system. So in this system, I have equation number 1, which is y equals 2x minus 2. And then equation number 2 on the bottom is 3y plus 6x equals 18. So this little guy right here is what groups together the system. That's all that is. So when you are told to graph a system, first thing, like we just said, is we need to know the slope and the y-intercept. So in order to do that, we need to know, first of all, what form is each equation written in?
The first one is slope intercept. The second one is standard.
Good, nice job. This one is in slope intercept form and the other one is in standard form. Now, which of those is easier to graph right away?
Slope intercept.
Yeah, slope intercept, because that one already gives you pretty much everything you need. What do I know about this equation?
We know the slope and we know the y-intercept.
Yeah, what's my slope?
2,
What's my y-intercept?
-2.
Very good. Very good, Jaira. Nice. We're not forgetting too much over break. That's good. Okay. Well, now that I know the slope and I know the y-intercept, I can actually use that information to graph my line. Where do I begin? Where is my first point going to be?
At the -2.
Good. Remember that the y-intercept, guys, is always your first point. That's the first thing you put down. And this is going to be at 0, -2. So I go down here and I put down my y-intercept. From there, how do I figure out where to go next?
We put a 1 at 2 over 1.
So in other words, my slope, okay, my slope, is a whole number right now. So I can turn that whole number into a fraction. Why do I want to do it as a fraction?
Because we need to find the run, and I forgot what the other.
The rise and run.
Yeah, the rise and the run. Yeah. So which of those two numbers is my rise and which one is my run?
2 is rise, I believe, and then 1 is run.
Good. Remember, it's rise over run. Exactly. So what does that actually mean? Rise means I go how many?
You go up 2 times and you go right.
Yeah. So up 2, right 1. We'll be practicing this again and again and again today. This is, I know we just had a break, right? So we kind of got to wake up that part of our brain where we stored all of this information. So from my first point, I go up 2, and then I go 1 to the right.
Miss, I have a question.
Go ahead.
Like when it comes to finding the when it comes to like doing the this like finding like how many places you need to move, is it always going to be 1 as the run?
No, because what if, for example, I'm just going to write an example up here. What if you had y equals 4 over 5x plus 3? What would be my rise? What would be my run?
Rise
Oh,
would be
so it's different when it's a fraction.
Exactly. So if it's a whole number, then yes, it's always 1 on the bottom, because that's how you turn a whole number into a fraction. You just put a 1 underneath. But if it's already a fraction, then you don't do anything extra. You just, that's your rise, that's your run. That's it.
Okay, thank
Good
you.
question. All right, so I've got my 2 points. That is enough to make a line. I'm just going to connect them and then keep going. And there is line number 1. So I'm just going to label that as 1. All right, any questions on how I graphed line number 1? Now, again, line number 1 was in slope intercept form, which is a little bit easier than standard form. Because what's wrong with standard form?
We know nothing about it.
Yeah, standard form doesn't give us any useful information in just one by looking at it, right? Like we can do some stuff to it to make it better, but just by looking at it, it doesn't really help us out. So there are 2 strategies for graphing in standard form. Can anybody name one strategy?
Where you put a 0 in the x, I believe. I forgot. I'm sorry.
That's okay. No, that's okay. You are on the right track. Does anyone else want to jump off on it? Like, why am I putting zeros in different places? What does that help me find? So for example, what Rajara was kind of saying would be to put a 0 in for x, right? So if I just plug in a 0, what is that going to help me find in the end?
Oh wait, or maybe we could move the 6x to the right side.
You're thinking of that's the other strategy, but I'm going to keep going with the one you started with because you're not wrong. This is a strategy. And it's totally okay if nobody remembers. I just kind of want to see if anybody might kind of have an idea.
If we do that, that means the 6 will go away and we'll be left with 3y and 18.
Yeah. 3y equals 18. And what can I do now?
Divide
Divide by what?
3.
Yeah. And when I divide by 3, what do I get? I get y equals what?
Y equals 6.
Y equals 6. Now, what is that number?
Y-intercept?
Yes, that's exactly right. That is my y-intercept. So what you just did, Ajara, was you found the y-intercept by plugging in a 0 for x. Because remember, when you plug in 0 for x, you end up with the coordinate point for your y-intercept. Because now I have 0, comma 6. 0, comma 6 is up here. That's my y-intercept.
Oh, okay.
But now I can do the same thing, except where should I plug in my 0 now?
For the y.
Exactly. Because now if I do the opposite, what am I going to find? Not the y-intercept, but the
X-intercept.
x-intercept. Exactly. So that is the first strategy that is one of two strategies for working with standard form. When you're in standard form, you can plug in a 0 for x and then solve and get your y-intercept, and you also have to do the opposite. So I'm going to go ahead and do the opposite now. I go back to my original equation, and this time I'm going to plug in a 0 for y, which cancels out, right? 3 times 0 is 0, so that cancels out. Now I have 6x equals 18, and when I divide by 6 on both sides, what do I get?
3.
3. And that would be my x-intercept. Because again, we plugged in a 0 for the y coordinate, which means my full coordinate point is 3, comma 0. So that's over here. That's how I got 2 points now. I can always, once you have 2 points, you are good to go because now you can connect them and finish your graph.
That's an easier strategy then.
It's a pretty easy strategy when the numbers are easy. Like in this one, it was easy because when you divide, it came out with nice whole numbers, everyone's happy, and we're good to go. But it's always good to know both ways of doing it. So now, does anyone have questions on strategy number 1 before I go on to strategy number 2? And again, we'll do this a couple more times. So if you're kind of still like waking that up, that's okay. Okay. Now, strategy number 2, Ijara started to mention it before. Do you want to say it one more time, Ijara?
We put the 6x, we transfer it to the right side.
Transfer it to the right side. And why are we going to want to do that?
Because we're trying to isolate the y.
Very good. When you isolate the y, what form is it going to end up in? So it's in standard form now. What form do we want to transform it into?
Slope-intercept?
Slope-intercept, exactly. Y equals mx plus b. So we want to try and get the y all alone. So like Ajira said, we want to take this 6x and transport it to the other side. Now, how am I going to do that? How do I move that over?
Oh, since we can't do nothing, since
Mhm.
the 6x is a variable,
Mhm.
we can't do nothing with it. So we do 6x plus 18.
Not quite, because there is a very specific way to move it over. And it's going to involve you either add it, subtract it, multiply it,
Take
or
out the
divide it.
X.
Take out the x.
Mm,
Think
what if
about
we
it.
put an X by the 18?
Subtract.
We want to get it by the 18, right? Like we want to move it to the same side as the 18. And I think I heard somebody say it. What operation should I use?
Subtract.
We're going to subtract. Exactly, Bianca. We're going to subtract. Now, why did she choose subtraction?
Because I forgot.
so I
Out
don't
my
know.
mind.
Don't worry. What is already next to the 6x?
A plus.
A plus sign.
Yeah, it was already a plus sign, so you always want to pick the opposite of what you see. Since we saw a plus sign, we're going to pick subtraction to move it, to cancel it out. That's the whole point of moving things over, is to be able to cancel them out. So since addition is the opposite of subtraction, that's how we cancel things out. So I'm left with 3y. And then how should I write this part? Should I write 18 minus 6x or the opposite way?
Opposite way.
Yeah. So I'm going to write negative 6x plus 18. And that's just because we want to write it as y equals mx plus b. We want it to kind of be in the right order. So that's why I'm writing it with the 6x first and then the 18. So all I did so far was I moved that 6x over. It became negative. I'm not quite done though yet. What should I do? What's the last thing I have to do to isolate my y?
You have to divide everything by 3.
Good. Got to get that 3 out of there. So the only way to do that is by dividing.
I'm so happy I remember that.
Good job. All right, so I divide everything by 3. So what's negative 6 divided by 3?
Negative 2.
Mm-hmm.
Negative 2. X.
X. And then 18 divided by 3
6.
is
Plus
6.
6.
Perfect. And now I'm in slope intercept form, and I can do the same exact thing that I did for my red line, which is to identify the slope, identify the y-intercept, and then graph. So what is my slope? What is my y-intercept?
Slope.
Negative 2x is slope.
Mm-hmm.
And the y-intercept is 6.
Beautiful. And just like my first graph, I go to my y-intercept, and notice I already graphed this green line. I'm just going to do it again because that way we can see it the other way. But you'll see we end up with the same exact answer. So I go up to the 6. I put down my first point, okay, at 0, 6. And from there, I have my slope is negative 2, but I need that to be a fraction. So what would that be?
Negative 2 over 1.
Negative 2 over 1. Since it's negative 2, what direction does that tell me to go in?
Down.
Down 2. Down by 2 and 1 to the right. So I do that. Down 2, 1 to the right. And I could do it again and again. As long as you can do it for as long as you want. You only need 2 points, but it is always nice to have more because then you can be a little bit neater when you connect them. So there's my line. It's the same exact line as before. We just graphed it a different way. And now that I have my 2 lines and I've graphed them, I can find what the actual question is asking, which is the solution. We need to figure out what is the solution. So where do I look again for the solution?
X. The intercepted, where they intersect.
Where they intersect. And now that we're this topic, like I mentioned at first, it's a little bit different. It's not just the X value anymore that I'm interested in. I want the whole coordinate point. So what is my solution?
We look at the blue dot, and then our solution is 2, 2.
2, 2. That's it. Okay. So this is kind of a two-in-one review, right? We're reviewing how to graph things and we're reviewing what it is to find the solution. So this is good. This is why this is one of my favorite lessons of the year, because I know you guys just got back from your break, but we're doing a lot of review and this is going to kind of like bring you back to what algebra is all about. Any questions? We will do a lot more examples. So any questions so far? Okay. Now we're going to go ahead and do example 2. Like I said earlier, if you don't have time or the space or whatever to graph all of this in your notebook, that's okay. You will have an opportunity to practice that during the homework tonight. So I would suggest definitely like just do the homework today. That way you do it and you're done with it, but it's not due till Wednesday. All right, here's another example. Again, we have 2 lines. Which of these is going to be easier to graph? 1 or 2?
1.
1. Because again, 1 is written in slope-intercept, whereas 2 is in standard form. So we're going to basically do the same exact thing that we did in the previous example. So I am going to go kind of a little bit faster now since we've already like learned how to do this, but I still want to hear from you guys. So equation number 1, y equals negative 2x minus 2. What is my slope?
-2.
Is negative 2. What's my
Negative 2x.
y-intercept? And y-intercept is also negative 2. Now remember, when I'm asking for those numbers, you always look at the symbol in front of your number. So if you have a minus sign, that's a negative. If you have a plus sign, that's positive. And that always goes that way. And just like the previous example, I go ahead and I graph. My first point is 0, comma, negative 2. That's my y-intercept. And from there, where do I go?
Down 2, right 1.
Down 2, right 1. Good, because this is also the same thing as negative 2 over 1. So I know that this is down and this is right. Down 2 over 1. And again, I could do it again just to get a neater line. Okay. So there's line number 1. Is that a positive line or a negative line?
Negative.
Good. Negative because the slope is negative. Okay, now I have to deal with the second equation. Now, it's in standard form. I know I have 2 strategies. What do you guys want? I'm only going to use one. Should I use strategy number 1, where you find the intercepts? Or should I do strategy number 2, where you have to isolate the y? Go ahead and put it in the chat. Tell me which strategy you want. Strategy number 1 or 2? It's tied right now. I need one person to break my tie. Okay, strategy number 2 wins. Okay. And then in the next problem, we'll do strategy number 1. So we'll flip back and forth. So strategy 2 is to solve or isolate this y. We're trying to get y all by itself in order to turn it into slope-intercept form. So right now, what should I move to the opposite side?
X.
Yeah, that x has to get out of there, right? It's got to move, go away. Should I add, subtract, divide, or multiply?
Subtract.
Good. Good, yeah, we're going to subtract. Minus x and minus x. So I have 2y equals, how should I write that?
Negative x plus 2.
Good. Negative x plus 2. And my last step to get y all by itself is?
Divided by 2.
Divided by 2. Everything gets divided by 2. Now, what does that mean about my x value? It's a little weird.
Well, there's a negative, I mean, there's a invisible 1 by the x. So
Mhm.
we can just say that as 1, I believe.
Right, so there is a negative, there's an invisible 1. So it's technically negative 1x. But now I'm dividing it by 2, so how can I write that?
Negative 2? Wait,
Well, think about it this way. What is 1 divided by 2? Would that be a whole number or a fraction?
Fraction.
Yeah, David, that's going to be a fraction. What fraction is it specifically?
1.5, because if you divide 1 divided by 2, it equals 0.5.
Okay, good. And you can always do what you need to visualize it. Basically, like if you have $1 and you want to split that in half, you have 50 cents, right? If you have a pizza and you split it in half, each person gets 4 slices out of 8. That's 1/2. So we end up with 1/2. But it's negative 1/2, don't forget. So negative 1/2 x. And then 2 divided by 2 is
1.
1, yeah. Any number divided by itself is just 1. So here we go. We have our equation. Y equals negative 1/2 x plus 1. What's my slope?
We have to do the intercept first. So 1, then go down 1, then go to the right 2.
Yeah, so the y-intercept is 1. The slope is negative 1 over 2. So first I'm going to go to my 1, my y-intercept. And my slope tells me to go where? Where does that tell me to go? Up, down, left, right, where am I going?
I'm going to let the others say because
Okay, thank you. Give someone else a chance.
Down, miss.
Down, yeah. Down 1 and 2 to the
Right.
right. Good. So here we go. Down 1, 2 to the right. Down 1, 2 to the right. Down 1, 2 to the right. Here's my line. There we go. And we can now finally get our answer. Where is my solution to the system?
n- 2, comma negative 2 or negative 2, comma 2.
Help her out. Which one is it?
-2,
-2, comma 2. Yeah. Remember that it's x comma y. So -2 on the x-axis, +2 on the y-axis. -2, comma 2. That's my solution. And I'm done. Okay, so again, we're really just reviewing how to graph lines. There's just that one extra step at the end where we have to figure out the solution. But at the end of the day, this is just one big review on how to graph a linear equation. How are we feeling? Questions, comments, concerns?
A little confused about this new because I'm always looking at the x instead of the y and the x. So I'll get used to it.
You'll get used to it. Yeah, well, we have all week to get used to it. So what I'm going to give you guys next is an example to do on your own. But like I said, it's kind of hard to graph this on your piece of paper and then like show me what that looks like. So all I want you guys to do is I have my 2 equations just like before. For both equations, tell me what is the slope and tell me what is the y-intercept. And then from there, we'll graph it together. So I'm going to give you guys about 2 or 3 minutes because this one is a little bit easier, and you'll see why in just a second. But go ahead and find the slope and the y-intercept for both. Okay, about 15 seconds remaining. If you have any questions or answers, go ahead and put them in the chat for me. Okay, all right, that's time. So for equation number 1, that one's my easy one because that one's already written in slope-intercept form. So for equation number 1, what is my slope and what is my y-intercept? What is my slope?
2,
2. And y-intercept is
8.
8. Easy enough. Where do I begin? What do I do first?
Start at 8.
Yeah, start at the 8. So I'm going to put a point on the 8. That's up here. This is going by 2s, right? So always make sure, or is it, wait, no, 6? No, it's not. It's going by 1s. So it's all the way at the top. Okay, so it's up here. So this is 0, 8. And then where do I go from there?
Up to, right?
Right, so this is telling me to go up to right 1. However, that's not going to work out for me, is it? Because if I try to go up, if I try to go up 2 and right 1, that's going to be like way off the grid. So what can I do instead?
Up 1, right 2.
Not quite. Think
Start from the bottom.
Start from a lower point.
start from a lower point, but I don't know, like the only point I know is the y-intercept. I don't know any other point. But there's something else I can do.
Turn the 2 into a negative.
Okay. If I turn the 2 into a negative though, what else do I have to turn into a negative?
A 1.
The 1, yeah. Basically, with any slope, you can either go up, like in this case, up 2, right 1, or flip it around and do the complete opposite. I could go down 2
To
and
the
left. Yeah.
Oh, so wait. So that means we times everything by -1.
Mm-hmm. Exactly. Because think about it. If I go up 2 and write 1, I'm like up here somewhere, right? Somewhere up there. And I would keep going because it's a line, and a line goes in both directions, right? It goes upwards, but it also has to go the other way. So if you continue the same pattern in the opposite direction, I'm still doing, this is still up 2, right 1. But if you think about it backwards, that's down 2, left 1. You kind of get what I mean? Like you can always flip it completely around and just do the opposite. So that's what I'm doing in this problem because I can't go off the grid into like outer space. So I'm just going backwards. And I connect my dots kind of neatly, maybe. There we go. All right, there's my line number 1. What about line number 2? If I want to get y all by itself, what's the only thing I really need to do? Okay, so subtracting 6 is something I can do, but like that's technically something I can do. But is that going to help me get my y by itself, or is that just going to keep adding more stuff to the side that I want to get rid of?
But in this case, drop the y.
Add x.
Okay, so I heard subtract y or add x. Now, subtracting y, again, is that going to help me get y by itself, or is that just going to keep adding things to the wrong side?
Keep adding things.
Add it.
Yeah. So remember, what we're trying to get all alone is the y. So the one that has to go away is the x. Always think about who needs to move over. Which one needs to go away so that y can be all alone? So yes, so we add x. Now, why am I adding x again?
Because it was already a negative.
There's already a negative. We do the opposite, which is to add. And what am I left with here?
X plus 6.
X plus 6, exactly. Now, this is slope-intercept form. What is the invisible number in front of the x? Yeah, so that's technically a 1x. So what's my slope and what's my y-intercept?
Slope is 1. B is
B is 6. Okay, so again, I go to the y-intercept, the 6, and I put my first point at 0, 6. Now, what do I do with that 1?
go down.
1 as a fraction is the same as 1 over 1. So this is telling me to go where?
up 1 to the right 1.
Mm-hmm.
But if we continue to do that, it will be the same as example 1.
It'll be pretty similar, but is it going to be exactly the same?
No?
No. They're a little bit different because one of them has a slope of 2, the other one has a slope of 1. So it might look like they'll have the same slope, but then when you do it, you'll see that they actually do cross. So where is my solution?
-2, 4.
-2, 4.
-2, 4. Good. Okay. So this one was a little bit tricky just because the graphing part of it was just a little bit trickier to like realize that you could go backwards. However, still the same process, right? We still found the y-intercept and then used the slope to find the next point. How are we feeling now? Any other questions so far? Okay. All right. So we kind of got the basics down. Now I want to look at some special situations because we know that there are three types of solutions, right? You can have one solution, which is what we've seen so far. This has one solution, and one solution. But what do we know can also happen?
Infinite solution and no solution.
Infinite solution and no solution. So we're going to see if we can figure out what special case we have in this example. What I want you guys to start doing first, just on your own, is the same as the previous example. Figure out your slope and your y-intercept for both of these equations. I have to go grab my charger, so I'll be right back. Okay, I'm back. So again, finding the slope, finding the y-intercept, and then before we graph, we're going to see whether there is something interesting going on, what similarities we see, what differences we see. Just about one more minute. Send me in the chat if you have your answers. What is the slope? What is the y-intercept? All right, for number one, for equation number one, what is my slope?
Two.
Slope is 2. Y-intercept?
-2.
-2.
-2. Okay, so I go to that point, 0, -2. And now, okay, in this example, the graph, the grid is going by 2's, notice, right? 2, 4, 6, 8. So we got to be careful when we graph that we're doing it by 2's. And then my slope is 2, so I know that this is telling me to go where?
Up 2
Mm-hmm.
and to the right 1.
Good. Up 2, 1 to the right. So again, since my grid is going by units of 2, I have to be a little careful. I go up 2, which puts me at 0, comma 0. And then I go 1 to the right. So I'm only going halfway because this is 2. So I'm only going halfway. So there's my second point. And then same thing, I go up 2 and over 1. So there's my other point, and now I'm going to connect.
Oh, I didn't see the graph. I thought this was like going from ones, but this is 2, 4.
It's by 2s, yeah. So that's just something to keep in mind. If you always want to look at the numbers first before you just go ahead and start putting dots everywhere. All right, so there's my first equation. Second equation is in standard form, so I need to move who needs to move over?
X.
Yeah, that x has to go. Should I add 2x or subtract 2x?
Add.
We're adding. They cross out, and I'm left with y equals
2x plus 4.
2x plus 4. All right, so my slope is 2. My y-intercept is 4. And before I graph this, let's predict. Do you guys think this is going to be no solution or infinite solutions?
No solution.
No solution. I see some people are saying infinite solutions in the chat. So let's find out. Remember, no solution means that they're never going to touch. Infinite solution means that they're touching always. So let's take a look.
Solution.
Let's take a look. So I start where? I start at the 4, which is up here. And then I have the same slope, right? So I'm going up 2 and then 1 to the right. Up 2, 1 to the right. Up 2, 1 to the right. And what do you guys think? What does this look like?
Parallel, no solutions.
Yeah, this is parallel. They have the same exact what?
Slope.
Same slope. Same slope. This is no solutions because they're never going to touch. They're never going to meet up. Now, they have the same slope, but what's different about them? They had the same slope, but when we were figuring things out, what was different?
The y.
Yeah, the y-intercept is different, right? For equation number 1, the y-intercept was -2, but for equation number 2, the y-intercept was +4. So whenever you have the same slope but a different y-intercept, that's no solution. Okay, any questions on this one? Okay, so that's one special case. Now let's look at a different special case. Same thing as before, figure out what is the slope and what is the y-intercept. Actually, let's do this one together. Real quick. So for number 1, my slope is
3.
3. My y-intercept is
-3.
-3. So I go to the -3, and where do I go from there?
Up 3, right 1.
Good. Up 3, right 1, and I'll do it one more time. Up 3, right 1. Connect my dots. Boom, easy. There's equation number 1. That's how fast you should be able to do it once you kind of really get the hang of it. It goes quick. Now, equation number 2, we got to move things around. -3x plus y equals -3. Who goes away? Who moves?
-3.
Good. What should I do to it?
+3.
We're going to add it to both sides. So what does that leave me with?
Y equals 3x -3.
3x minus 3 or 3x negative 3, which means, well, what do we notice?
Our slope is 3. Our
Mhm.
b is -3.
Mm-hmm. And what do you guys think? Is this going to be no solutions or infinite solutions?
Infinite.
Yeah, because at the end of the day, what do we have? We have
The same slope and the same y-intercept.
same slope, same y-intercept, and put that together, we have the same exact equation. It's exactly the same, y equals 3x minus 3. So if I go to graph the green one, well, I'm going to do the same exact thing. I go to -3, I go up 3, 1 to the right, up 3, 1 to the right, and I end up with the same exact line. Right smack on top of the other. Now, it's a little bit messy, but basically they're one on top of the other. So we have infinite solutions.
So that's how we figure out the infinite solutions.
If they have the same slope and the same y-intercept, you have infinite solutions. And that is pretty much everything, okay? So quick review. No solution, they have the same slope, but they have a different y-intercept. Infinite solutions, they have the same slope and the same y-intercept because they're right smack on top of each other. Questions, comments, concerns, suggestions, objections, anything at all? All right, I want you guys to try it one last one by yourselves. This one's a little bit different, so always think to yourself, if I need to get y by itself, who needs to move over? Okay, try it on your own. Figure out the slope. Figure out the y-intercept. And then see if it's going to be the same, or if it's going to be infinite solutions or no solutions. About 30 more seconds. And when you have your answers, try to predict, is it going to be one solution, no solutions, infinite solutions? Okay, all right. So for equation number 1, what do we got? What do we got? What's my slope? What's my y-intercept?
Slope
I'll
is
let this
-1,
question go for now.
Okay, someone else.
-1.
So my slope is -1. Good. Remember that if there's no number in front of your x, there's an invisible one. So this is technically -1x. So the slope is -1 and the y-intercept?
-2.
-2. Now equation number 2 is a little bit weird. Everything's kind of off on one side, right? We've got x and y and 2 all on one side. So more than one thing is going to have to move over. What can I move over first?
The 2.
Sure, let's move the 2. There's no wrong answer there. I can subtract 2 on both sides, leaving me with x plus y equals -2. And now what?
Move the x.
Move the x. Should I add it or should I subtract it?
Subtract.
Yeah, good. And that leaves me with y equals, and remember we always write x first and then the 2 and then the other numbers. So I'm going to write y equals -x minus 2. Which means do I have the same equation or 2 different equations?
The same.
Same exact equation, same exact. So my slope is also -1. My y-intercept is also -2. So before I even graph this, what do I already know?
It will be the same line.
Would be the same exact line, which means what type of solution do I have?
Infinite.
Good, this is infinite solutions. Let's see what that actually looks like. So where do I begin? Where do I put down my first point?
-2.
And remember, this is going by 2's, so I already noticed that about the graph. So my first one is there, and then where do I go?
Down 1, left 1.
Down 1,
Right 1.
right 1. Yeah. Down 1, and then 1 to the right, because the 1 that we placed underneath is positive. So it's -1 on the top, which tells us to go down, but then it's +1 in the denominator. That still tells me to go to the right. So I go down 1, 1 to the right. Now I'm going by 2's, so I'm kind of floating in the middle right now, but I do it one more time, down 1, 1 to the right, and putting it all together, here's my line. And since we already know that they are the same line, I'm not going to do it again because it's just going to be one line on top of the other. Or I could just do my other line right on top. Infinite solutions. Questions so far? Questions at all? We're almost done. We're just going to do a couple of different problems now. But this is the last one of graphing. So any questions on graphing? Now on your homework assignment, let me see if I can actually pull it up so you can See what it looks like. Give me 1 second. I might be able to like share my screen so you can see what it looks like. Yes, okay. Let me share my screen. Once it loads. It's kind of taking a moment, but okay. So here's what the problems actually look like. So it shows you your system. Now, some of these are harder than others. In this example, what is both of these equations written in?
Standard.
Yeah, both of them are in standard form. So you might get one like this where you have to figure it out from standard form twice, but not all of them are like this. Some of them are, both of them are in slope intercept form. Some of them mix it up. So you'll get a different one depending. But anyways, you'll have your system and you have your answer choices, but you also have a graph. So what you can do is take a look at your system, figure out what the graph is going to look like. So if I quickly do the first one in my head, hold on. That's going to be y equals 2/3 x plus 2. I just did that in my head. Don't stress. You will have time to do this on your own. But basically, you can look at this graph and move these dots around until you've got the graph you need. Right? So after you've put them together and you've figured out what the graph looks like and you can graph it on your own, you'll find the answer. So the second one, again, I'm just doing this in my head really quickly. Oh wait, this would be negative. The other one would be y equals 4/3 x plus 4.
Ms. Lopez, question.
Yeah.
What is wrong with the answers? I'm seeing, I don't know, there's 0, y. What? I don't understand.
So, okay, so this is, instead of giving you a coordinate point, they're just giving you, they're breaking it down. So really what this is, for example, let me just, for example, example A or answer choice A is the same as 0, comma, 2 2/3. So they're giving it, they're breaking it down. Instead of a coordinate point, they're giving you the x value and then the y value. This is the same as -1, comma, 3 2/3.
Okay, I was a little confused. I'm
Does that make
sorry.
sense? You're good. And so based on my actual example, you kind of have to estimate it, but where do these two seem to be crossing? This is -1, comma, what?
2 point something.
2 point something, right? So which answer choice does that look like it's going to be?
C.
Looks like it's answer choice C, yeah. -1, comma, 2 2/3. Now, I hope I did this right. Let's find out if I did it right. I kind of did it quickly in my head, so I don't know. Yes, okay. So that's how it's going to go, okay? You have the graph. The graph is there so that you can find the answer, but then once you have the answer, you click the correct one. And it's not the easy, like I know that this is not going to be the easiest assignment in the world, so I am giving you only one assignment this whole week, and this is it. So I'm also giving you the video that is on here that you can watch, which might be helpful as well. Okay.
The following two.
So that is that. And we have about 10 minutes left. So let me, hold on, let me share my screen again. I want to decide if I want to do this or not. I have 3 more problems. They're not too hard, but they're a little bit different.
Word problems.
Yeah, so I have some word problems. And I just want to show you really quickly a different way to solve a system of equations without graphing. So let's say you don't have a graph in front of you for whatever reason, you can do things algebraically as well. Let me show you how. It's like I said, it's not too hard. It's more like reviewing things we've done before. So let's see. Cora ran 3 miles last week and will run 7 miles per week from now on. Hannah ran 9 miles last week and will run 4 miles per week from now on. The system of linear equations, shown here, can be used to represent the situation. Explain what x and y represent in the equations, and then after how many weeks will Cora and Hannah have run the same number of miles? How many miles? And it says solve by graphing, but I'm going to ignore that.
Oh.
Because we're not going to graph. We're going to do things algebraically. We want to know after how long will they run the same amount. We want them to be the same, okay? So when you don't have a graph in front of you, I mean, if I did have a graph, I could graph it and then find the place where they do what?
Intersect.
Where they meet, where they intersect, right? But since I don't have a graph, I'm going to try some algebra. Now I want them to be the same. That's the key word. We want them to be the same. So what I can do is I can take equation number 1, the top one, just this part of it, 7x plus 3, and I'm going to make it equal to the bottom equation, 4x plus 9. Because we want them to be the same. That's the key word. We know that in order to be the same, they have to be equal. So when I make them equal to each other, I'm going to solve it like an equation and figure out what I get for x. So this is where we're going to review solving equations. Can anybody tell me if I'm trying to get x by itself, what should I do first?
Combine. Well, combine like terms.
What do you mean by that?
Well, we move the 3 to the right side. It will give us -3, and we combine like terms, which is -3. Wait. 9 negative divided. I mean, -3 or 9. Hold on. Okay.
Oh no, it's okay. You're on the right track. You can move the 3 over, but before I do that, I want to move something else over. What should I move first before I start moving the numbers, the 3 and the 9?
Oh, the 4x.
And what operation should I use?
Subtraction.
Subtraction property.
Yeah, we're going to subtract 4x. Where should I take it from, the 7 or the 3?
7.
Good. Okay, 7 minus 4 is 3, so I have 3x plus 3 equals 9. Now, Jaira, now let's move over that 3. Oh, I'm getting a phone call. Hold up. Take that later. Okay, so now I can move over that 3. What should I do to move it? Add, subtract.
Subtraction property.
Another subtraction property. What's 9 minus 3? 6. And to get the x all by itself?
Divided by.
Good. So we divide by 3. And yeah, I got x equals 2. I get x equals 2. However, remember the solution, now in this whole chapter, we're talking solutions. We need a coordinate point. We need x comma y. So right now I only know that it's 2 comma something. I don't know what the y value is. But luckily, I have 2 equations in my system that I can plug in the number 2. So for example, I can take the top equation just from my original problem, y equals 7x plus 3. And since I already know that x equals 2, I can go into that equation and plug in 2. And let's find out what we get. So 7 times 2 is
14.
14. And 14 plus 3?
17.
17. So my x was 2, my y was 17. So the solution is 2, comma 17. Now, what does that actually mean? Because they also want us to know what the x represents and what the y represents. So reread the problem if you need to reread it. But what's that going to be? 2 what and 17 what?
I believe the 2 is the weeks
Mm-hmm.
and the 17 is the miles.
Very good. Very good. So after 2 weeks, both Cora and Hannah have run the same amount of miles, which is 17 miles. So that's what this represents. So we'll do that. This is kind of a preview for tomorrow's class. We will do a little bit more of this tomorrow. But the main focus for your homework is graphing. So just make sure that if you need to, you rewatch this whole video or parts of it, or watch the video that I'm putting on Khan Academy. Do what you need to do to kind of review that process so that you feel good about the homework assignment. All right, it is 10:42. It's pretty much time to go, but I do have time for any questions if you guys have any final questions. Okay. All right, so again, homework is due Wednesday at midnight. It is already up on Khan Academy. Please start the new year fresh, guys. If you were kind of behind on your homework last year, all right, make that your priority this year. Work on that homework. Make sure you get it done in time so that you can have the best
Bye,
grade
Miss.
possible. Bye, everybody. Have a good day.
Have a nice day, Miss Lopez. See you tomorrow.
See you tomorrow.